In a game, a die is rolled. To win, a player must score a 3. What is the probability that a player first gets a 3 on the second roll? So if the player first gets a 3 on a second roll, they have to not get a 3 on the first roll. So in this case, the player must fail on the first throw of the die and then get a 3 on the second throw. So we first draw our tree diagram as normal, noting that there are 2 possible outcomes that we are interested in. Rolling a 3, which is success, or not rolling a 3, which is failure. So we have 2 branches at the start for the first roll, rolling a 3 or an F, which stands for failure. So basically rolling a 3 or not rolling a 3. If we roll a 3 on the first roll, then on the second roll we could roll a 3 or we could fail. So again, we could not roll a 3. If we fail on the first roll, so if we don't roll a 3 on the first roll, on the second roll we could roll a 3 or we could fail again by not rolling a 3. So the outcomes are 3, 3, 3 fail, fail 3, and fail, fail. So remember, F equals failed to score a 3. We next fill in the probability of the 2 events on the tree diagram at every branch where these events occur. So we need to fill in our tree diagram now. So remember, success is rolling a 3, and the probability of rolling a 3 is 1 over 6. There's 1 3 on a die, and there are 6 possible outcomes. So rolling a 3, the probability is 1 over 6. So failure means they did not roll a 3. So that's going to be 5 over 6, because there are 5 options on a die that are not a 3. It's 1, 2, 4, 5, and 6. So 5 over 6 is the probability that the person will fail. Alternatively, we could have said 1 minus a sixth leaves us with 5 over 6. Because rolling a 3 and not rolling a 3 are 2 mutually exclusive events, they have to add up to 1. So the outcome we are looking for is F, comma 3. So that means fail on the first throw, land on 3 on the second throw. So failed to roll a 3, succeeded in rolling a 3. So this is what we're looking for. So we have to fill in our branches. So in the first branch we're going to have 1 over 6 because the probability of landing on 3 is a sixth. And on the other branch we're going to have 5 over 6 because the probability of failing is 5 over 6. Then we fill in our second roll branches. So again, the probability of landing on a 3 is 1 over 6. The probability of failing is 5 over 6. The probability of landing on a 3 is 1 over 6. And the probability of failing is 5 over 6. We follow the branches of the tree diagram, noting the probabilities from the start to the desired outcome. So we're looking for F comma 3. So we see this is F comma 3 here. So that's fail and then get a 3 the second time. So fail on the first roll, get a 3 on the second roll. So F comma 3. So remember, we need to multiply. So and means multiplying probability. So fail and 3 is going to be 5 over 6 multiplied by 1 over 6. So 5 over 6 multiplied by 1 over 6 is going to be 5 over 36. So the probability that a player gets a 3 on the second roll is going to be 5 over 36.